Hi, I'm Yiyun, and in this project, I developed a machine learning model to predict the customer churn using the Taco customer churn dataset. So I begin the notebook by loading and preparing the dataset. So the telco dataset contains information about like customer demographics, service, billing information, and whether like the customer eventually churn. So after loading the dataset, I perform some basic processing steps. These steps including some like cleaning columns, names, converting certain variables into numerical format, and also handling some missing values. For example, like the total charges column sometimes appears as a string or blank value, so it's converted to numeric while invalid values are handled appropriately. So these processing steps ensure that the dataset is clean and suitable for modeling. So after the processing, the dataset is divided into training and also test sets. This step is important for validating model performance because it ensures that the model is evaluated on unseen data. By using a holdout test set, we can measure how well the model generalizes rather than just memorizing the training data. The next step in the working flow is anomaly detection. I use an isolation forest model to identify potential outliers in the dataset. Anomaly detection helps identify unusual customers whose behavior differs significantly from the majority. So these anomalies can provide additional insights into churn behavior and help us understand whether unusual customer profiles are more likely to leave the service. And also, after identify this, I moved onto building predictive models. I trained two classification models, and one is the logistic regression, and the other one is a random forest. Logistic regression is choosing because it is relatively simple and also interpretable, while random forest is used because it can capture more complex relationships in the data. Both models are trained using the training dataset and evaluated on the test dataset. To measure performance, I evaluate several metrics, including accuracy, precision, record, and also F1 score and ROCUC. So accuracy measures the overall percentage of correct predictions, while precision measures how many predicted churners are actually churners. Recording measures how many actual churners are correctly identified by the model. And the F1 score balances precision and recall, and RockArc measures how well the model distinguishes between churn and non-churn customers across all possible thresholds. So using some multiple metrics provide a more complete evaluation of model performance. After comparing the results, the best performing model is selected. I then analyze different decision thresholds to balance recall and precision. So in churn prediction, identifying potential churners earlier is important. So using a slightly lower threshold can increase recall and also allow the business to target more at-risk customers. And next, I focus on the model explanations. I also generate local explanations using Lime. Lime explains individual predictions by approximating the model locally around a specific data point. This allows us to understand why the model predicted churn for a particular customer. For example, the model may may predict that a specific customer will churn because they have high monthly charges combined with a short tenure, and a flexible contract type. These local explanations improve transparency and make the model easier for stakeholders to understand. I also implement, so this part is for like local explanations. And I also implement counterfactual explanations using the DIC framework. Counterfactual analysis identifies minimal changes that would alter the model's prediction. For example, the model may indicate that if a customer switched from a month-to-month contract to a longer contract, the predicted churn risk would decrease. These counterfactual explanations are useful because they provide an actionable insights that business can use to reduce the churn. And beyond interpretability, I also evaluate the fairness. So about the fairness, responsible AI requires ensuring that models do not unfairly disadvantage specific groups. To assess fairness, I calculate the fairness metrics such as demographic parity and equalized odds across demographic groups. These metrics help determine whether prediction rates or error rates differ significantly across groups. Evaluating fairness helps ensure that the model's predictions are equitable and that potential biases are identified. Another important aspect of responsible AI is reliability. So, to evaluate the reliability, I examine calibration and probability predictions. Calibration analysis helps determine whether the predicted probabilities correspond to actual outcomes. Reliable probabilities estimates are important because they help business prioritize the customers based on risk levels. And also finally, based on all the model results and explanations analysis above, I provide a business recommendations. So the model identifies several factors associated with higher fraud risk, including the short tenure, month-to-month contracts, and also higher monthly charges. So in conclusion, this project just demonstrates how machine learning models can be developed while incorporating the responsible AI principles. So by combining accurate predictions with transparency and fairness, the model can support responsible and informed decision-making in real-world business contexts. That's all. Thank you for listening.